Alright, so we looked at the law of sines, and now we're going to look at the law of cosines. Just like the law of sines can be used to find any side or angle measure for any triangle, same for the law of cosines. So we can find any side length or measurement for any triangle. Alright, so what we're looking at again is we're still looking at reference angles and sides. Whatever side or angle we are trying to find, we're going to start with that side measure. So if I'm trying to find either reference angle A or side A, I'm going to say A squared is equal to then my two other sides, so B squared plus C squared minus 2 times, again, these two non-isolated sides, so BC times cosine of whatever reference angle is for my isolated side here, so cosine of reference angle A. Likewise, if I'm trying to find side B or reference angle B, I'm going to say B squared is equal to my other two sides, A squared plus C squared minus 2, these non-isolated sides, AC times cosine of reference angle B. And if I'm trying to find side C or reference angle C, C squared is equal to A squared plus B squared minus 2, my two non-isolated sides, AB, times cosine of reference angle C. Alright, so we're going to look at what that actually means here. So here I notice that I have an unknown side X, but it's across from this 65 degrees. So I know that this is the corresponding side angle measure here. So I'm going to say I'm trying to find X. So I have X squared is equal to my two other sides, 7 squared plus 12 squared minus 2 times these non-isolated sides, so 7 times 12 times cosine of the corresponding angle to my X, and so that's going to be reference angle 65 degrees, so cosine of 65. And then I'm going to solve from here. So we have X squared is equal to 49 plus 144 minus 168 times cosine of 65. I'll combine 49 and 144, so I have X squared is equal to 193 minus 168 times cosine of 65. Now I want to find X, so I can just take the square root of this whole thing. So we have the square root of 193 minus 168 times cosine of 65, and we get 11 rounded to the 10th, so we get X equals 11. Alright, so you say, well, we found the side, but how do we find the angle measure? So the same thing is going to apply here, alright, but we're just going to find the angle instead of the side. So here I see that I'm trying to find angle X, okay, and it's corresponding to this 21 for my side. So I'm still going to say, we know that the side isolated corresponds with the angle. So if I know I want angle C, I want to isolate side C. So I want angle X, so I want to isolate this 21. So 21 squared is equal to my other two sides, so 16 squared plus 26 squared minus 2 times my 16 and 26 times cosine of X, because that's what I don't know. Alright, so then I have 441 is equal to 256 plus 676 minus 832 cosine X, and 441 is equal to 932 minus 832 cosine X. So now I'm going to just isolate this 832 cosine X first. So I'll subtract that 932 and get negative 491 is equal to negative 832 cosine X. Now just like before, the X has to do with the degree measure, and that's what always goes with that cosine. So I can't just divide by negative 832 cosine because it's going to want that X part. It's going to want some degree measure. So I want to divide by this negative 832 first. And so I'll get that 0.5901 is equal to cosine X. Now I can solve for X. So we know that dividing by cosine is the same thing as multiplying by cosine negative 1, right? So we know that this will be the same. So we'll find cosine negative 1 of 0.5901, and we get 53.8 degrees. So I know that x is 53.8 degrees. All right, so what I want you to do is I want you to try number 2 and 4. So pause the video, try those, and then when you're done, you can start it back up and check your answers. Right, you should have paused the video and answered, and you should have gotten for number 2, x is 36.5, and for number 4, you get 32 degrees. So now this concludes our law of sines and law of cosines, so we know how to find the sides and angles of right triangles and non-right triangles. You will now have a review of some law of sines and cosines in addition to some other of the trigonometry review. So this concludes our notes.